All right. Good morning. Happy Monday. Good morning. Second to last Monday. So everybody have a nice weekend. Saturday was gorgeous. Yesterday was nice too. Saturday was like that perfect clear day. We're going to continue talking about probability today. And the probability that we look at today will start combining two events together, two things occurring, one or the other thing happening. So we're going to look at that. Tomorrow we don't have school. On Wednesday, we'll look at conditional probability. And then on Thursday, we'll look at the probability of independent and dependent events. So pretty much each day we're still talking about probability, but the type of events when there are two events together kind of just change slightly, which means we have to find the probability slightly differently. Friday and Monday next week, we will review probability, and then your final test. Remember, there's not a final exam in here, but your final test is next Tuesday, the 25th. So that'll be the last test of the school year. And it is on probability. So again, this Friday and Monday, we will review for that test on Tuesday dealing with probability. So your worksheet from over the weekend from Friday was just on probability of an event. And there were two worksheets that were front to back, both section 10.3, part C and part B. And I had the numbers labeled for you to complete. The answer key was at the very bottom for both parts for you to kind of look at and reference. I wanted to go over two of them with you, and then if there's any others that you want to talk about, we can, but just as a little refresher as well of probability, we'll kind of work through a few of these. Probability and odds is what we talked about on Friday. So I want to look at number 6 first. Number 6, the directions for 1 through 8, which you had to start at 4. But the directions say you have an equally likely chance of choosing any integer from 1 through 80. Find the probability of the given event. So essentially, if you were playing bingo and you put balls in that big bingo turning thingy and they were numbered 1 through 8, we want to find the probability of choosing one of those balls out of the little turning thingy, whatever that's called. I'm not sure. But number 6 says you want to choose a factor of 200. So all of the bingo balls are in this huge container, numbered 1 through 80. We want the probability of getting a factor of 200 if I could pull out one of those balls. So how could you find the probability of choosing a factor of 200 from the numbers 1 through 80? So how could we at least start? What could you be thinking about? Well, we have 200. We could probably start by listing the factors of 200 so that we know what numbers go into 200. And I know 1 and 200 would be a factor of 200. 2 and 100, and I'm just going in order here so that my pairs kind of match up. What other factors are there of 200? What else goes into 200? 3 doesn't. Does 4 go into 200? Riley, how many times does 4 go into 200? 50. Do you know 5? How many times does 5 go into 200? 40. Does 6 go into 200? How about 7? 8? How many times does 8 go into 200? 25. So if I have 8 quarters, I got $2. 9 doesn't, but 10 goes into 200. Not. How many times does 10 go to 200? 20 times. Yeah, okay. My brain's like blanking for Monday. Are there any other pairs? 15. Does 15 go into 200? $12 doesn't go into 200. Any other pairs? Anybody get any others? So this would be our list of factors of 200. Now remember, we only want the numbers of 1 through 80. So after you have your list of factors, I'm going to go through and cross off the ones that aren't from 1 through 80. So 200 is a factor, but it's not in my list or my group of numbers from 1 through 80. 100 is a factor, but again, it's not in my list from 1 through 80. So if I count the remaining factors, 1 is still a factor, 2 is still a factor. So looks like I have 10. So the probability of getting a factor of 200 would be 10 out of 80. So the number you're looking for, the number that is in my list of factors of 200 from the values of 1 through 80 out of the total of 80 choices. And then I can reduce that to 1 out of 8. So those first group of problems, numbers 4 through 8, you're looking at the specific piece of information they're giving you. How many numbers in that set from 1 through 80 match the information that they're giving you? Are there other questions in 4 through 8? So I wanted to do the next one as well in the next group. These are talking about odds though. And now we're just talking about the numbers of 1 through 20. So you have a 20-sided die. And on that die, there are numbers 1 through 20. And they either say the odds in favor or the odds against. So if you look at number 13, the odds in favor of rolling an even number less than 10. Ella, how many even numbers are there less than 10? So 4 even numbers less than 10. So when we're doing the odds in favor, what you're looking for goes first. What you don't want goes second, or the number that are left over. So Ella, how many numbers are left over? 16. So odds are different than probability. Odds compares for versus against. Successes versus failures. So 4 of the numbers were successes because there are 4 even numbers less than 10. The rest of them, God bless you, the 16 are greater than 10. Ella, what would that reduce to then? Right, 1 to 4. So your odds, write those as a ratio with a colon in between, comparing the odds. But again, odds are different than probability. Probability takes the total. Odds are comparing what you're looking for versus what you're not looking for. So for versus against, successes versus failures. All right, the last one that I wanted to talk about, trying to see a couple of different types of problems here, was from the last group of problems on the next page. And in this case, you rolled a die 200 times and then kind of kept track of all the numbers you were rolling. So the numbers on the die are 1 through 6. That's up here at the top. And then the numbers on the underneath would be how many times you rolled a 6, how many times you rolled a 5, how many times you rolled a 3, and so on. So the last question you were asked to do, number 10, says rolling any number but a 1 or a 6. So we want to find the probability of rolling any number but a 1 or a 6. and we rolled the die 200 times. So that should go on the bottom. How would you find the probability of rolling any number but a 1 or a 6? Gabby Snyder, how could I find the probability of rolling any number but a 1 or a 6? So which ones would I'm not, which ones are not a 1 or a 6? So I want to roll any number but a 1 or a 6. So which ones aren't a 1 or a 6? Right, 2, 3, 4, and 5. Those are the ones that are not a 1 or a 6. But you need to add the numbers underneath, because those are the times that you actually rolled the die and got a 2, you got a 3, you got a 4, you got a 5. So you need to take the 15, the 40, the 36, and the 44 and add those values together. So you're using the actual data. This is called experimental probability, when you use actual data and add that together. Somebody have that number? Gabby? Yeah. And then that reduces to 27 over 40. So experimental probability, you're still finding what you're looking for out of the total, except you're using actual data from something that occurred. So I'm not just saying a 2 out of 6 or a 3 out of 6. I'm saying it's out of 200 because I rolled the die 200 times. Are there questions? So I tried to go over one type of problem from each of the different things that we did on Friday. So regular probability, looking at odds, looking at experimental probability. Are there others that you wanted to go over or ask about? So as I said, we're going to continue talking about probability today. We're just going to kind of add a little extra piece to it because we're going to look at 2 different events happening. So rolling a die in probability is considered an event. That's the name of it. So the occurrence of an event is probability. So in your notes, if you can turn to section 10.4, we're going to talk about the probability of disjoint and overlapping events. And then, as I said, tomorrow we're going to talk about something called conditional probability. Not tomorrow, Wednesday. I keep saying tomorrow. And then Thursday, we'll talk about something called independent and dependent events. So looking at 2 things now and just kind of slightly changing those. So compound events, if you have a compound, and I know you're all not in chemistry yet because you'll be in there next year. And all my chemistry students are taking the Keystone for English. I have a compound event. That means 2, a compound, 2 or more. So this is the union or intersection of 2 events. So you have 2 events. How are they combined together? How do they intersect? Last year in geometry, closer to the beginning of the year, you looked at Venn diagrams and you looked at the union of events in Venn diagrams. You looked at the intersection of events in Venn diagrams. We're going to draw 3 different little Venn diagrams just to get a kind of a picture of what's happening. So the first one here, we're going to say this is the union of 2 events. So we have event A, we have event B. The union, let's highlight this instead. is both of the events or all of the Venn diagram, all of the bubbles joined together. So whatever events are in A are joined together with the events in B. So that's called the union of the events. So everything in A, everything in B. The intersection is just the little overlapping area. So here's A, here's B. The intersection is that small area where they're overlapping. That little small area that they both have in common. That's called the intersection. And then there's one final option that I could have two events that don't intersect. That don't have anything in common. And these are called disjoint. So I have my events in A, I have my events in B, but they don't have anything in common with each other. So looking at the two terms underneath, overlapping events would be two events that have something in common. They have a common outcome. So either they have everything in common or they have this little portion in common. But overlapping events are two events that share a common outcome. So they're going to have something in common. They're going to intersect somewhere. So of course, the other term, and you'll see both of these words used, disjoint, mutually exclusive. Disjoint, they're separate from each other. Mutually exclusive, they're separate from each other. So two events that have no common outcomes. And again, you'll see either word. You'll see the word disjoint or you'll see the word mutually exclusive. But they are separate, they don't connect, they don't have anything in common. So today we're going to talk about what we call the addition rule. But really, we're going to be finding probability of compound events. So two events occurring, one or the other event happening. And there are two different formulas for the probability of compound events. So if A and B are any two events, then the probability of A or B. So the key word here is that we're looking at the word or in both of these. This is one event or the other event happening. So the first probability, if I want to find the probability of A or B, I take the probability of A, add it with the probability of B. So or means add. And we talked about this with combinations and permutations of multiple events. But then you have to subtract the probability of the overlap. So I'm finding the probability of A, I'm finding the probability of B and adding them together, but I have to subtract that little part that overlapped because they both have that piece in common and I can't count it twice. So the overlap is the probability of A and the probability of B occurring. The second formula says that they're disjoint, meaning there is not going to be any overlap. And that formula is just taking the probability of A and the probability of B. The two outcomes are not connected with each other, so I don't have to subtract anything because they don't have anything in common. So it's just the probability of A in addition to the probability of B. So again, OR means add. We call it the addition rule. So looking at the first three problems here, you roll a six-sided number cube, a six-sided die. What's the probability of getting a 2 or a 5? So this one starts off pretty straightforward. We want the probability of getting a 2 or a 5. Cody, how many numbers are on a six-sided die? How many times am I going to get a 2 or a 5? About 2 out of 6 times, which reduces to 1/3. There's 1, 2, there's 1, 5 out of the 6 numbers. So about, and it is true. It's about, that's what's supposed to happen. So about 1 out of every 3 times. The second question, what's the probability of rolling an odd number or a number less than 3? I'm going to use the inequality there. So Jaden, let's talk about odd numbers. How many odd numbers are on a die? How many numbers are less than 3 on a die? Yeah, just 2. You're good. So I'm taking the odd numbers, which are 1, 3, and 5. Those are the odd numbers. The numbers less than 3 are 1 and 2. So I have 3 out of 6 and I have 2 out of 6. However, the number 1 is also less than 3. That is called your overlapping event. I counted it as odd, but then we also counted it as less than 3. So we have to subtract 1 out of 6 because one of those numbers was counted twice. So 3 odds, 2 numbers less than 6, but the number 1 was counted in both of those. That's the overlap. So Jaden, if you take 3 out of 6 plus 2 out of 6, subtract 1 out of 6, you end up with, which would be 2/3. So this here is the overlap of the events. Questions? So if we look at the third one, cards, you randomly select. A card is randomly selected from a deck of cards. What's the probability that it's a 10 or a face card? So probability that you get a 10 or you get a face card. Ella, how many 10s are in a deck of cards? 4. Do you know how many face cards are in a deck of cards? 12, yeah. Remember, your Jack, Queen, and King are your face cards. There are 3 face cards and 4 suits, so there are 12 of them. Ella, is a 10 ever considered a face card? No. So they are separate events. A 10 cannot be a face card. It's a 10. So you don't have to subtract anything. Ella, if we add those together, we get, and that reduces to 4/13. So you can see 2 of them were disjoint, and the one in the middle had that overlapping piece. Questions? So the next problem is a little word problem where we're going to try and use the formula for compound events. So we're going to try and use this formula here. And our goal in this formula is going to be to find the and part. Find the part where they both occur, which is that overlapping middle part. So I'm just going to write the formula here. So the probability of A or B, this is called the addition rule, is the probability of A plus the probability of B minus the probability of both. So that's the overlapping part. If there isn't overlapping, there's no overlapping part, then I don't need to do that subtraction part. So this says out of 200 students in a senior class, a little smaller than us, we are somewhere in the range of probably 300 to 325. So 200 students in a senior class. 113 of them are either varsity athletes or on the honor roll. That sounds like important information there. So varsity athletes or honor roll. 74 seniors are varsity athletes. And then finally, 51 seniors are on the honor roll. What's the probability that a randomly selected senior is both a varsity athlete and on the honor roll? So let's look through it again and see if you can kind of fill in the pieces of information into your formula. Our goal is to find both. What's the probability that they're a varsity athlete and also on the honor roll? How many students does that apply to? So looking at that first sentence again, 113 students are either varsity athletes or on the honor roll. Gabby Soul, where does that piece of information go? So 113 students are either varsity athletes or on the honor roll. How many total students are we talking about? Total. 200. You're good. It's okay. It's a Monday morning. So 113 of those students are either varsity athletes or on the honor roll. So that's the A or B part. 113 of them are one or the other. So out of the 200, 113 of those students are either athletes or on the honor roll. All right, Gabby, I'm going to come back to you. How many students would just be either a varsity athlete or separate on the honor roll? So how many varsity athletes do we have? 74. And how many honor roll students do we have? 51. Now, I know you're saying, hey, wait, 74 and 51 don't make 113. Yes, that's because there's overlap. Because some of those students are both. And that's what we're trying to find. So now we're going to subtract the probability of A and B, and that's going to become our variable in this equation. So we have the number of students that are either varsity athletes or on the honor roll. And then individually, we have the varsity athletes. Individually, we have the honor roll students. But how many are both? How many partake in both of that information? Now, you have a common denominator. So we just need to solve this. You're solving for A and B. That's our variable. So Jaden, if we add 74 and 51 together, what do we get there? 125. So we have 113, 125, and then Jaden, how would you solve for both? Yeah. And when you subtract that over to the other side, you end up with And because they're both negative, 12 out of 200 students are both on the honor roll and are also varsity athletes. So find the probability that a randomly selected senior is both a varsity athlete and on the honor roll. That's going to happen 12 out of 200 times. That's the both part. That's the overlap part in those little diagrams. So I have everybody that's a varsity student, everybody that's a senior athlete on the honor roll, and then that both part in the middle where they're both senior athletes and on the honor roll. Questions? So the last thing that we're going to look at today is the probability of a complement of an event. The complement of the event can sometimes be thought of as the opposite. So if you would say opposite, that would be the complement. The complement has a little hat on top of the A. And that's found by taking 1 minus the probability of the actual event, because I want the opposite of it. So if you look, there's a little diagram here. If I roll 2 dice, there are 36 possibilities if I roll a pair of dice together. So think you're playing Monopoly. And you roll a 1 and a 6, so you move 7 spaces. But you could also roll a 6 and a 1, and you still move 7 spaces. So there's 36 combinations. This says we want to find the sum, or we want to find the probability that the sum is not 6. So our goal is to find the probability that the sum is not 6. The easiest way to do this problem is to take 1 minus the probability that you get a sum of 6. Guess I should put the word sum here. So if you look at your pairs of dice, you want the pair of dice to add together to be 6. And if I can find that sum, then I should be able to find its complement, which would be the fact that it's not 6. So Riley, do you see any pairs of dice that add to be 6 on here? How many of them add to be 6? Yeah, so 1, 6, 2, 4, 6, 6, 4, 2, 5, 1. Notice they're in a little diagonal as well. So she said that would be 5. So we're taking 1 minus 5 out of 36. Because the rest of them don't add to be 6. And that's what we're trying to find, the probability that the sum is not 6. I want the rest of them. So 5 of them do add to be a sum of 6, and the rest of them don't. So Riley, what would be 1 minus 5 out of 36? So if I take 36 out of 36 minus 5 out of 36, you get 31 out of 36. So that means if I count the rest of the dice, there's going to be 31 other pairs. All of those other pairs don't have a sum of 6. All right, let's look at letter C. Let's hop down to letter C. Find the probability that the sum is greater than or equal to 3. So our goal is to find the probability that the sum is greater than or equal to 3. We'll use our little inequality sign there. What's the opposite of being greater than or equal to 3? You're not greater than or equal to it, you are less than. So let's find the probability that it's less than 3. So I'm going to take 1 minus the probability that my sum is less than 3. Well, if you look at these dice, pairs of dice here, how many of them have a sum less than 3? Jane? Only one of them, that top left corner. That's the only pair of dice that has a sum less than 3. So to find the probability, I would say I'm taking 1 minus 1 out of 36 because there's only one time where the sum is less than 3. So Jaden, that means the other, how many pairs would be greater than or equal to 3? The other 35 out of 36 pairs. So complements are using the opposite to make it a little easier to find the probability. Now, could you have counted all of the other ones? Sure. You could have said, well, there's really 35. If one of them aren't, 35 of them are. It's just giving you another way to look at it. So the last problem I want to do, let's go down to the very last example on the next page. Cards and probability, lots of different examples with cards. You're picking one card from a standard deck of 52. Find the probability that you get a red or a black card. Grace, how many red cards are there in a deck of 52? Yeah, how many black cards are there? Also half. What's the probability of getting a red or a black card? What's that? 1. Because there aren't any other colors. You either have red cards or you have black cards when you have a deck of cards. So the probability of getting a red card or a black card is just 1. Looking at part B, the probability of choosing a face card or a red card. So now I want the probability that we get a face card or a red card. So Ella told us before that there are 12 face cards. Grace just said half of them are red, 26 out of 52. So 12 face cards, 26 red cards. But how many face cards are actually red? 6 out of 52. That's that overlapping part. So you're finding the probability of a face card. You're finding the probability of a red card. But then you have to subtract the part that's both. Because you counted red cards, you counted face cards. And then there happen to be 6 that are both. So if we add 12 and 36, or 26, and then subtract 6, I think that makes 32, which is 8/13. Questions. So your homework is a worksheet on the addition rule. You'll be using that formula, the probability of A plus the probability of B, and then minus the both if there is a chance or an occurrence where they both occur. Have a fantastic day. See everybody tomorrow. There are no bells right now because of Keystone testing going on. So have a great day. See you guys tomorrow. Actually, Wednesday. I keep saying tomorrow. That whole like Tuesday, man. That's throw me off. It is.